And our final session is about deploying AI models at scale, digital twins for industrial heating grids. Here to tell us more, we're going to have Victor Pereboom, who's co-founder and CTO of UbiOps, and Tanja Crijns, who is a digital twin engineer, cool title, at Gradyent. So please welcome Tanja and Victor to the stage.
Hello. Welcome, everyone. Thank you so much for joining. I hope you're having a great first day at the summit, and hope that you already got a lot of inspiration from the talks earlier today. So in this talk, we'll dive into really deploying AI and machine learning systems into production and deploying AI models at scale, which is kind of a huge and more important topic right now, as we're seeing so many companies kind of reach the point where they kind of worked a long time and many years on really developing and building AI models and training the models themselves, but now kind of reaching the point where they have to actually run them in production, and also create working and scalable AI systems. And you see this across the board, like in healthcare, in infrastructure, finance, but also in what Gradyent is doing with in kind of the energy in the energy space. So I think we're seeing a huge shift here, where kind of productionizing AI and ML is becoming like a much bigger thing than it was a few years ago, and that's not only because it's fueled by the availability of foundation models and models you can take off the shelf and kind of deploy, but also because just seeing a lot of companies kind of getting out of this experimental phase, and we're starting to look more about how we're going to actually apply AI in practice and how can we kind of get value out of it when it's running in production. And with that, kind of inference is slowly becoming a more important thing than training, and we're reaching an era where we're starting to think about how can we actually run things at scale in the cloud, how can we build reliable AI applications that actually have a great kind of benefit and value for society as well. So I'd like to take you through kind of a couple of stages, kind of how you build, how you get to the point of where you have a scalable AI product, kind of starting out with a proof of concept or beta. And I made this nice drawing of kind of a journey up a mountain, where we start kind of at the point that we've talking about for a lot of years now, like how do you create good models, and how do you build your data science workbench, and how do you get kind of value out of your data. But once you reach the point of a working prototype and a working product beta, like how do you get to the point where this model actually runs in a reliable way, like 24/7 availability, maybe in the cloud or in a data center, and how do you ensure like security and reliability? And once you have that, like how do you make that product ready for like thousands of users to actually make use of? And how do you get to the point where you maybe not have like one product, but multiple products or AI systems running in production at the same time? So let's start out kind of below, kind of in the kind of valley of experimentation. I'm not going to spend too much time here because it's been covered so many times in the past couple of years, and most companies kind of have a maturity in developing AI systems and also having a data science workbench experimentation stage ready. And once you get to the POC or product beta stage, where you have something that's actually tangible and kind of shows value, that's usually the point where a lot of companies are right now. So you have, let's say you have a machine learning model, you have it running maybe on your laptop or on your local system, and you can kind of take that and show it to customers and show like, hey, look, this is working. Do you want to buy it, or can you actually use this? And that's the point where you also, kind of want to look further into like next steps. And the only thing that's changing in this part is actually that I think foundation models and off-the-shelf models are really accelerating how much time companies are spending in this space. But let's not forget that there are like thousands of use cases where kind of large language models or transformers are not really applicable because maybe a statistical model or more traditional machine learning actually does a better or like more efficient job. Like applying a transformer on like linear regressions may be a bit overkill. And there are tons of use cases there, and those models also need to kind of make their way into a scalable product. So what does it actually mean, kind of having a scalable product? It means that suddenly, instead of looking at experimentation, we're actually looking at kind of production, kind of thinking about how do you deploy a model, but also how do you monitor it, how do you actually govern it, and how do you make sure it's reliable? Because in the end, with AI in production, suddenly you have to take care about a lot of non-AI and machine learning related things. So suddenly you have to think about how do you make your system reliable, how do you guarantee any like uptime when the model is running live, how do you guarantee like security of the data and the information. And this is a lot of things for a AI like data science team to think about. So suddenly you need a lot more kind of capabilities. And a couple of things to kind of keep in mind is suddenly the system needs to be reproducible. So what was firstly like just code running on a local machine, suddenly you kind of need to guarantee that the code that's running locally is also the same code that you tested and now is running in production. Things need to be maintainable, so you want to kind of have a life cycle, implement kind of a life cycle for the model itself. And you also want the things to be robust all of a sudden. So instead of having, let's say, your local kind of server or Dockerized server with a Python API attached, suddenly you need to think about that a system needs to be live 24/7, and what do you do with failover, and what do you do if things actually break maybe. And then there's the security and compliance part, which is really important in production systems. People are going to ask questions about, hey, where's my data going to be processed? Like, what do you do with GDPR, or how do you ensure compliance, or how do you ensure that things are actually secure? And so suddenly, while this AI model kind of stays the same, the whole complexity of the solution actually explodes. And this is kind of the part where a lot of data science teams, a lot of teams get stuck in really building deployment and kind of production-ready solutions, because they have to think about API management, like monitoring, building a life cycle and CI/CD around your data model, version control of data models, all that kind of stuff. Think about Docker, think about Kubernetes, like scalability. And it's a lot of things at the same time. And we're also seeing that kind of MLOps and solutions and tooling that kind of sits between your data science code and your infrastructure are kind of the solution for kind of getting to this step. Like two things, just like about the actual, let's say, model governance and maintaining the lifecycle of this model, as well as kind of the cloud part and the tooling to actually deploy things and run things scalably in production. So once you get to this point of, let's say you have a model and it's running in the cloud, it's up and running, you have ensured kind of this maintainability and availability and the security as well. Now you want to turn it into a scalable product, which is really like a next stage and like a next level, because suddenly this thing needs to scale up and down, and it needs to be not just available all the time, but you also wanted to scale it with demand. So let's say that you have a solution where you're a growing company, you deployed an AI solution, but now suddenly you are kind of thousands of users using your product. And how are you going to scale automatically? But also, how do you keep costs in check? And how do you also scale down when maybe the model is not used all the time? How are you going to guarantee kind of resource availability? We're seeing that kind of GPUs are becoming a difficult kind of resource and piece of hardware to have access to like all the time. So how are you going to ensure that? And one interesting development that I want to dive into a bit is like a hybrid cloud. So how are you going to scale across environments? For instance, if your data is not allowed to leave a certain kind of the premises, or you want to kind of overflow or scale out to the cloud as well. So about this scaling part, so what you want to do essentially is preferably scale with demand, right? So if there's a lot of traffic coming to your solution or your model, you want to make sure that a lot of pods or kind of AI model kind of replicates itself and scales horizontally and is able to process all that data at the same time. While in the meantime, also ensuring that if it's not used, it doesn't consume any resources because, yeah, scaling in the cloud, especially on GPU hardware, can be really expensive. So you actually want to have the model and have the solution kind of follow this demand curve as well as possible in order to also not just keep up with the incoming traffic, but also kind of keep your cloud bill and resource usage in check. So it also frees up resources for other kind of models and things. And one of the recent developments, now the models become larger and the models become larger, and they also, yeah, you need the scalability. Access to GPUs is a very kind of tricky thing to get right. So that kind of goes hand in hand with that they're also not very available and they're very expensive. So you see, one of the things to tackle that is to look into hybrid and multi-cloud setups where you have different pools of GPUs and also can guarantee access, especially have a kind of a highly scalable solution. Not just in, let's say, a single cloud, but maybe pull resources from different clouds as well. So you see a lot of users or a lot of companies looking at hybrid and multi-cloud strategies, not just for this resource problem, but also to kind of solve the compliance and security issues by bringing compute kind of closer to the data. Right, so with those kind of things in place, you kind of reach the point where you have a scalable AI product. And now to kind of make that tangible and illustrate it, I'd like to give the floor to Tanja from Gradyent. And they, with their team, kind of reached that point. And yeah, really happy to kind of hear how they did it.
Yes. Thank you, Victor. Thank you for also having me here. So Victor introduced or invited me to come here, talk to you guys about how we use UbiOps as a product. So yeah, as he said, my name is Tanja, and I'm a machine learning engineer at Gradyent. We are a company, we've been collaborating together with them for about 4 years now. We're a startup, and we started roughly around the same time. Our company builds software for heating, for companies that have heating grids. And for those who are not familiar with the concept, the heating grid concept, so we build software for heating grids and industrial heating. District heating, for example, is a way, instead of having a boiler at your home to heat your house, you have one central location in an area where heat is generated, and the heat is distributed over the network via insulated pipes to industrial areas or to residential areas to be used for space heating or for water heating. And we build this software for energy companies that are currently in the midst of an energy crisis. So they are looking for ways to do better. They're looking for ways to become more sustainable. So we help them try to reduce their carbon emissions, but also help them transition to more sustainable energy sources. And we do that by building digital twin software. And how you can imagine that, it's kind of like a bundle of quite complex physical, but also artificially intelligent models that we have working together to build a pretty accurate digital replica of these networks that often lie underground and very invisible. These models are often run in parallel, or they run sequentially, and we train a model for each of our customers. And after the initial training period, we have a 24/7 simulation of the network where we get sensor data from the customers and we update the network constantly. And to orchestrate all this, we use UbiOps as a tool to deploy our models in a scalable and reliable way. Well, personally, I already have some experience with cloud development, but that's not the case for all of our engineers. Most of them have a very strong physics background, and this is also because that's where we add value for our customers, because our customers are not looking for cloud experts, they are looking for people that can really give them insights in stuff that they have trouble with themselves. So our engineers are mostly spending their time building these super intricate, complex little parts of heating grids that are very specific to each of the customers. And then after that, UbiOps helps us with the whole process of getting that to the cloud in a fast way. So that kind of brings me to the 5 benefits that we were able to. I think I missed a slide, so I think this is the abstraction layer that I was talking about. So instead of our engineers having to invest a lot of time learning how to develop something in the cloud, we can do that on UbiOps. That brings us to my final slide, where we have the 5 key benefits of our collaboration. First one, as I already said, ease of use. It takes 30 minutes to get a new engineer to deploy a model and have it running in production. Second one being that it's fast-paced. So we're a startup. We're often in a time crunch. Sometimes in the development phase, we have 30 models. We have to deploy 30 models in a week. So it's good to have that in a system where that scales up very easily. Second one, we have these 24/7 production systems, so we need to be reliable the whole time. Our clients are energy companies, so it's critical infrastructure. We need to have insight to the data, where is it going, who has access to it, and we have arranged a situation where they have a managed solution for us on our own cloud, so that we know where the data goes at all time, and it's compliant to the security demands of our customers. And lastly, of course, we are a startup. We have margins to take into account, and as we are not building the software we're building our own software, but not the cloud infrastructure from the ground up, we want to be able to have insight into how much we are spending and how much we are using, and that's also very much possible with UbiOps. Yeah, so that's basically what I wanted to tell you guys about my use case, and I'll hand it back to you, Victor, for the last part.
Yeah, thanks, Tanja. It's a really great technology what they're building, and it's great that we have our collaboration and we can help them kind of get it to market and accelerate that. So yeah, we're seeing that for most companies, it's really relevant to kind of fast track this kind of journey to productized AI and offering them a shorter time to market, kind of lower cost, but also having a solution that's also readily reliable and maintainable from the start. And there are a lot of tools, kind of the landscape of tools that you can use kind of along this journey is rapidly increasing, and you see that this whole MLOps ecosystem is expanding very rapidly, where it's also, you see teams starting to kind of handpick their preferred tools for filling in parts of this journey, but also, creating their own preferred stacks for, productizing ML and AI solutions. So yeah, from UbiOps side, our goal and mission is to help teams kind of get to that point of productized and having scalable and reliable machine learning systems by taking away the complexity of basically deploying, managing, and running these systems in production, and also giving them access to the right cloud resources and making it very easy for data science teams to kind of reach to this point. So talking about the mountain, we kind of help you get through all those stages, and making it easy to go from a proof of concept to really a scalable AI product. Now, if you want to talk, thank you very much for your attention and for joining this session today. If you want to reach out to us, I mean, our contact details are on the slide, or visit us at our booth, and happy to talk more about production AI and your challenges there. So thank you very much.
Thank you very much, both of you. Great advice and guidance and an overview of what you do, and a great case study as well. I want to open it up to our audience to say, have we got any questions for Victor or Tanja here? So I imagine, I don't know if people are being shy this afternoon, but there'll be a lot of people at this conference who are building an AI product and looking to scale it or aspiring to scale it at some point. And you've given a great overview of of how you can help them do that. But if you had one piece of advice of somebody who's sat in this crowd and doesn't want to put their hand up that would like to know your one-stage piece of advice as to how to think about scaling, what would you say?
I would say it's becoming totally like commodity, so don't spend your time too much on figuring all this stuff out yourself. Focus on what you're good at, which for most data science teams is really their domain knowledge and building great machine learning models, not necessarily kind of figuring out all the cloud-related stuff.
Yeah. Focus on what you're good at. Sounds like sage advice. Thank you very much. Please give a huge hand to Victor and Tanja.
Thank you.
And now it is time for a break. You can stretch your legs, get some caffeine or whatever it is you prefer to do. Please visit our expo booth if you haven't done already. We will be recommencing at 4:20 p.m. So have a wonderful break, and please come back here to the main stage for some phenomenal talks. We've still got a lot more content to deliver. So yeah, see you back 4:20. Thank you very much.